and scenarios where we use it. So if you have a development pipeline, for example, you type your code, you send your code to your GitHub, and then automatically this is going to be sent to a machine somewhere and deployed. How does the machine connect? How does GitHub connect to the machine? Or how you when you send your code automatically gets accepted to GitHub? SSH pairs. Or your public is there on GitHub, so when you're sending the code, you say git push, it goes directly. Now, from GitHub to automatically go to the server, again, another key pair. The private key is on the server, the public key is on GitHub. So once it gets, it says, okay, it's allowed to connect to that server, the code goes here. So that's why the basic understanding of public and private keys is very important if you're into software engineering, computer science, even if you're doing AI and robotics, because you will use GitHub, you will use the CI/CD pipelines, you will have to connect to servers to deploy your applications, and business appears. Now, the last thing that I want to speak about is about hash functions. So basically, what hash functions do, they take a bunch of information, no matter how much information you throw at it, and it's meant to produce a specific size of, let's say, characters, bunch of ABCDs and numbers. Why do we use this? Where have you seen the use case like this? Take a bunch of text, convert it to a specific number of characters, totally randomized, and you cannot convert it the whole way. You cannot take, let's say, it produces 16 alphabets, that majuscule, minuscule, and can you convert it back to something else? You can. Simple example again. I'm using a tool called MD5 from Linux. I say MD5 key.png. This is a PNG file. It produces a bunch of numbers and characters. I use MD5 on another file, which is a GBD ISO file. It produces the same number of characters and numbers. Now, if you look at these two files, the key.png, the PNG file, the image file, is about 21 kilobytes. And the other one is 3.7 gigabytes. But still, the number of characters produced is on the same data. So where do we use these kind of systems and why it is important to have this knowledge? Anyone? Any idea? Yes.
To hide passwords.
Exactly. It's to password hashing. You're into software engineering, you're developing the systems. When your team creates an account in your system, he puts the password MSCC 2024. Okay, simple password. That password cannot go as plain text in the database. Because anyone who has access to the database will see the passwords of everybody. You need to find a mechanism to hide the password. So that you take MSCC 2024, you hash it, it will be a bunch of characters, it is saved in the database. Next time when you is going to log into the system, there's a function that will turn this into the hash, compare it with the hash of the database, and says, okay, it matches, so you can log in because you cannot have two exact hash on two different kind of systems. For example, this DVD ISO, if along the way I make one slight modification on this and I run MD5, the hash code will change. Even with a tiny modification of 1 bit, if I make to the bar, the hash will change. Now, it's a bit funny, but having a proper knowledge about how hashes work, how the hashing functions work in the software can save your lives. I will give you a scenario, a very specific scenario. I was working for one company, let's call it a managed services company. We had a big firm in a data center, and once we had a client who had an issue on the system. The client's systems architect in France was stuck in train. We could not reach the systems architect, and he was the one who had access to the system, and we needed to disable a few plugins. So the administrative access on the production side, on it they had access to that. We were the managers of the servers, not applications. So the client contacted us, they are not getting access, they are not being able to reach the systems architect, and the plugin need to be disable these and these and these plugins if we can find a solution. And we were thinking, what can we do? We have the full permission of the client to do whatever is needed to do that. So we asked the client, can we enter your systems architect account? They said yes. you can enter this account. But if you do not have this password, then you cannot reach the system's text password. So what is the best way to enter to log in into the system using the system's account? Anyone? Anyone? You know how hash functions work, right? And you know when the password is hashed, the password is saved in the database, right? But you cannot take the hash from the database and try to deduce the password. So what do you do? What is the next thing that we do? Exactly, to change it. So you take the hash, which is in the database, you keep it aside, and then you take another text, you hash it, for example, MSCC 2024, you hash it, you get that hash, you put it in the database, you log in with the password MSCC 2024, you do whatever changes, you disable the plugins, confirm to the client that, okay, all the plugins have been disabled, we are restoring your system's architect's password, so you take the previous hash, put it back. So when the system architect will come, he will not have to log in with MSCC 2024. He will log with his own password. But you have to intervene very urgently with the permission of the client. So this is what got done. So having a knowledge of symmetric encryption, public key encryption, and hash functions are, I believe, from my experience, these are three things that can save you from embarrassing moments and save you from very important scenarios. Yes.
Another important scenario about what is showing here with the checksum or hash on files is that you can verify that they are consistent, so that they have not been tampered. Because if we consider recent cases where there have been attacks on the supply chain of deployments, it was a situation that people can use link libraries or objects that are actually injected with malicious code and using the same file name. So you take a good file and you replace it with a malicious file, and it gets incorporated into the application. Yeah, if you want to do ransomware deployment, if you want to do crypto miners or whatever, you can use this kind of approach. However, if all the files have been hashed and the numbers, the hash values are available, any kind of system can then verify the current files against their hash values and see whether they have been tampered or not. And this is one of the important functionalities where you use hashing of files, just to make sure that all your, let's say, deployment pipelines, your distribution is still consistent and valid. Yeah, another global scenario for this case is actually all the installation servers, the mirrors for Linux distribution, because there are thousands of files and they need to be untampered. And this is happening by using hashes.
Exactly. I was about to give that example. Okay, you mentioned that. For example, if you're very basic example, I manage some Linux mirrors and versions. So let's say Dr. Sivan is updating an Ubuntu system here at the university. Okay, updating, therefore you upgrade. All your request goes to Ubuntu, but Ubuntu redirects that to nu.ubuntu.com because it says the closest mirror to you is the one which is here in Mauritius, and that mirror is managed by myself. Now imagine if I had some malicious codes and I said instead of LibreOffice, I'm going to change the package. In the package of LibreOffice, I'm going to put something else. So the next time you're updating your Ubuntu and LibreOffice, you get a malicious package on your system. But that cannot happen because Ubuntu systems, whenever they are updating their system, there are two things that they are checking. One, they check some values, whether this has changed, and second, whether all the packages, like you see on you might do it to use Ubuntu, all the packages are actually .deb packages. All these .deb packages are PGP signed by Canonical. So if I try to tamper with that, that signature is invalid. And then automatically your updater will prompt that does not match the source. Do you still want to persist and install it? It might contain malware or something like that. So it's important to have these kind of we didn't talk a lot about PHP. We mentioned it only for email purposes, but it's used in a lot of other places. And hashing functions, you will find it almost even in Windows. It's like that. When they're updating software, there are some hashing algorithms that checks whether whatever you have downloaded corresponds to what Microsoft has published. And if it's not, prompts you with